Graphing quadratic functions in standard form by hand. The quadratic function is y equals x squared plus 4x plus 5. We know this is a quadratic function because it fits the form ax squared plus bx plus c, where a is not equal to 0. Therefore, we have a quadratic term. In fact, the value of a is 1. In this equation, b is 4 and c is 5. So our first step in graphing this function without a graphing calculator would be to graph the axis of symmetry. And remember the formula that we've been using is x equals negative b over 2a. So the opposite of 4 over 2 times 1, it's the opposite of 4 divided by 2. The axis of symmetry is x equals negative 2, which I will graph. Now our next step is to find and graph the vertex, which I know lies somewhere on that axis of symmetry. We know that the x-coordinate of the vertex is negative 2, so we'll substitute negative 2 in place of x in the given equation. So y equals negative 2 squared plus 4 times negative 2 plus 5. Y equals 1, therefore the coordinates of the vertex are negative 2, 1. Now because a, the leading coefficient, is positive, I know that this curve is concave up. So when I go to find my y-intercept, which would be the next step, I expect it to be above the vertex. To find the y-intercept, when it's in standard form, I set x equal to 0, and so the y-intercept will always be the c value, the constant term, in this case 5. So here we'll plot the y-intercept. Notice that it's 2 away from the axis of symmetry, so we can plot the other point that's 2 away in the other direction. Here we have 3 points that lie on this curve. Step 4 is to find and graph another point that lies on the curve along with its reflection. So I like to use convenient values of x, such as x equals 1. We haven't done that yet, so we'll substitute x equals 1 into the original equation. 1 squared plus 4 times 1 plus 5. Therefore, 1, 10 lies on this curve, and here I've plotted it along with its reflection. And our final step is to graph this curve. So we'll do one more example. In this one, the leading coefficient will not be 1. Y equals 3x squared plus 18x plus 13. This again is in standard form. And here a equals 3, b equals 18, c equals 13. I know that this curve is concave up. I know that it's 3 times as steep as the parent function. So I'm expecting it a little bit more narrow. And step 1 is to find and graph the axis of symmetry using the equation x equals negative b over 2a. So the opposite of b over 2a, the opposite of 18 over 2 times 3, that's the opposite of 18 divided by 6, or negative 3. That's my axis of symmetry, which I've just graphed. Now step 2 is to find the vertex, which I know lies along that line. Let's substitute negative 3 in place of x, and we'll solve for y using order of operations. I get negative 3, negative 14. So it just fits on this curve. And next, I want to find the y-intercept, which is going to be easy to spot because this graph is in standard form, so I know the y-intercept is 13, which is 3 away from my axis of symmetry, so I'll graph the other point that's 3 away. And my last step here, before I connect these dots, is let's find one more point that lies on the parabola along with its reflection. So one other point would be negative 1, negative 2, because I substituted negative 1 in place of x. 3 times 1 is 3, minus 18 is negative 15, plus 13 is negative 3, 3 minus 18 is negative 15. Negative 15 plus 13 is negative 2, that's right. So there's our point, negative 1, negative 2. Now we'll find its reflection, and we will now connect these dots to graph the curve.